This video demonstrates different methods for how to mix animations using animation graphs. For an introduction to the concept of animation graphs, watch the linked video. In the first example, we use a pose switch node. This node takes a number of animations as input and an index to select which one to use. When the index changes, it automatically fades from the current playing animation to the target animation over a short duration. This allows us to smoothly transition from one animation to another and can be used to switch between very different animations. Be aware though that you need to make sure to reset certain animations to their start when activating them. Otherwise their playback may start somewhere in the middle. If you want to blend two animations, you can use the Lerp poses node. It also takes multiple poses as input. The number value is used to select the two poses to mix, and the fractional part determines how much to use from each. So a value of 0 selects the first pose, a value of 1 selects the second pose, and a value of 2 the third pose. Any value in between blends the two poses. So here we use it to blend the walk and jog animation. However, if you look closely, the leg movement sometimes gets out of step. That's because the two animations are not playing in sync. Sometimes in the walk animation the left foot is forwards, while in the jog animation the right foot is forward, which results in an awkward blend that doesn't look right. For such cases, there's the Blendspace 1D node. It works very similar to the Lerp poses node, but it takes care of sampling animations in a synchronized fashion. It is specifically designed for transitioning between walking and running animations. The important condition is that your animations are also authored correctly. That means each animation should be the same motion, just at a different speed. Note that you have to set the correct position of the clip, meaning at which Lerp value they will be fully active. This gives you more control at which speed they are being used. Now we can precisely control at what speed our character is supposed to walk. Next we take a look at the animation sequence node. Here we have a sequence for a jump animation. The first clip enters the jump state, then we have one looping animation for the duration of the jump, and finally an animation to transition out of the jump. When the jump state becomes active, we restart the animation from the beginning, and while it is active we continue looping the middle clip. Once the jump state is deactivated, the loop is played to the end, and then the end animation is played to finish the jump. Note that the responsiveness to the end animation depends on the length of your looping clip. Here the jump loop animation is nearly 2 seconds long, which means that there's a significant delay. Normally for such use cases you would make your jump loop animation extremely short. Alternatively, you could use another pose switch node to transition to the jump end animation at any time. However, the sample sequence node can also be used in a very different way. Here we don't use a start or end clip. Instead we've set up multiple middle clips. Usually the node picks one of these clips at random, but here we connected the clip index pin to control this ourselves. Now the node behaves very similar to the pose switch node, but with a crucial difference. We can change the clip index at any time, but the node always finishes playing the current middle clip before it plays the next one. This is very useful for animations that should always play out in full rather than being interrupted, such as shoot and reload animations. Again, the responsiveness depends on the length of your animations. In this example, the 2-second idle animation is always played to the very end before playing the shoot or reload animation. Of course, in such a setup, you never know exactly when your animation will play, which is why you should use animation events to let your game code know when a weapon fired or when to play the reload sound. For details about animation events, see the documentation. Finally, we take a look at a more complex example. Here we want to combine the walking animation with the attack animations. However, the attack animations should only be played on the top half of the body. For this we use the bone weights node. The node takes the name of a bone in the skeleton to construct a mask for all of the bones that should be affected by this animation. Here we selected the first spine bone, such that the torso, head and arms get modified. We use two pose result nodes, and the second node gets this bone mask to layer the attack animations on top of the base walking animation. Now we can easily control whether the upper body uses a different animation, and we can control which animation to play there.